Okay, so for this lesson, we're going to take a look at connecting the concepts of the roots, the zeros, and the x-intercepts. So first, when we're talking about the zero of a function, the zero of a function is figuring out whatever the value of the independent variable is when the dependent variable is equal to 0. So if I'm finding the zero of this function, if this is my dependent and this is my independent, I'm going to replace the f of x with 0. And I'm going to solve for the x. So I'm going to add 6 to both sides and get 2x, and divide both sides by 2 and say that x is equal to 3. If we're looking at connecting the idea of the roots, the zeros, and the x-intercepts, the roots and the x-intercepts we've already talked about, I have the graph of the function y is equal to 2x minus 6. Determine the x-intercept of the graph both algebraically and graphically. Well, if I'm doing it graphically, I'm going to look at where it crosses here, and the x value when it crosses is at 3. So this is at the point of 3 and 0, or the x-intercept. If I'm doing it algebraically, I know that the x-intercept is going to occur when y is equal to 0. So I'm going to replace y with 0 and solve for x. Add 6 to both sides, divide by 2, and I get the same value. In both cases, x is equal to 3. If I'm determining the root of this equation, the equation only has one variable, so I'm just solving for x. In this case, I'm going to add 6 to both sides, divide by 2, and state that the root is 3. State the connection between the x-intercepts of the graph and the roots of the equation. The x-intercept and the roots have the same value for x. If we look at the part that we've already done, when we solve for the 0, and it was still 2x minus 6, then it's the same. The 0 of the function the root of the equation and the x-intercept of the graph share the same x value. For the second example, Jacques is determining the roots of the equation x squared minus x minus 6 is equal to 0. First thing that he did was he wrote the equation in factored form and used the zero product law, which we did in the last lesson, in order to find the roots of the equation. So I'm going to start with the x squared minus x minus 6 is equal to 0. I'm going to factor this, and because the a value is 1, I'm going to need two numbers that multiply to make negative 6, but add up to negative 1. So I'm going to say that it's going to be x and negative 3 and x and positive 2 equals 0. At this point, I'm going to say that either one factor, x minus 3 is equal to 0, or the other factor, x plus 2 is equal to 0. Here, x would equal 3, and here, x would equal negative 2. And then I can state the roots are 3 and negative 2. For part B, they've done a graph of this, and they want us to state the x-intercepts and mark them on the grid. Well, here, I have the point of -2 and 0. Here I have the point of 3 and 0, which means the x-intercepts are going to be -2 and 3. If I'm determining the zeros of this function, anytime it asks for the zeros, I'm going to take the dependent variable and replace it with 0. 0 is equal to x squared minus x minus 6, and then I would factor it down, x minus 3, x plus 2, so either x minus 3 is equal to 0, or x plus 2 is equal to 0, and x is going to equal either 3 or -2. So what is the connection between the x-intercepts, the roots, and the zeros? The value of x is the same. Which means that I can state, if I'm filling in the blanks, excuse me, that the 0 of the functions, the x-intercepts of the graph of the function, and the roots of the corresponding equation, y equals 0, are all the same numbers. So if I'm looking at this graph, then in this case, I have the x-intercepts at -2 and 3, and I got a y-intercept at -6. I'm going to have the zeros of -2, not -3, and 3, and I'm going to have the roots of -2 and 3. When I'm describing how to use the features of a graphing calculator to determine the zeros of a function, I'm going to graph the function, f of x, into the y equals in the calc. Then, depending on if you have a TI calculator or you have a Casio calculator, what you're going to do next in the TI is you're going to do second, trace, and the number 2 to solve the zeros. If you have a Casio calculator, you're going to do shift, F5, and F1 to solve the roots. State the zeros of the function. Well, in this case, I have the zeros are at x is equal to 1 over 2, or x is equal to 3. What are the roots? The roots are 1 over 2 and 3. When I'm drawing this on here, I'm going to have one x-intercept at 1 over 2 and 0. I'm going to have 1 at 3 and 0. And then when I look at my equation, I know I have a y-intercept at 0 and 3. It's always going to be the constant of my equation. And then I would just connect these and expand out. It doesn't have to be perfect, but it generally shows us all the pertinent information. So, if I am algebraically determining the zeros of these functions, well, the first thing is I'm going to replace, to solve the zeros, the p of x or f of x with 0. For this first one, I don't need to factor it because it's already been factored down for me. All I need to know is that this is going to be 3 times x times 4x minus 9. Well, 3 can never equal 0, so that doesn't actually have an impact on what my answers are going to be. Just the x and the 4x minus 9, whichever factors have a variable. So then I can say either x is equal to 0 or 4x minus 9 is equal to 0. X is equal to 0 is already solved, so this would be 4x is equal to positive 9, or x is equal to 9 over 4. And in this case, x is going to equal either 0 or 9 over 4. In the second case, I'm going to start the same way. I'm going to say that 0 is equal to 5x squared plus 15x minus 20. All of these are divisible by 5, and because it's not an expression, it's an equation, I'm just going to divide both sides of the equation by 5, which means that I'm going to divide every single term by 5. And then I have the simplified equation, 0 is equal to x squared plus 3x minus 4. I'm going to factor this and say that 0 is equal to x plus 4 and x minus 1. And then I'm going to solve the possibilities. Either x plus 4 is equal to 0 or x minus 1 is equal to 0. This would give me x is equal to negative 4. This is going to give me x is equal to positive 1, which means that x is either going to equal negative 4 or positive 1. And those are my two zeros. For the last example, when it says algebraically determine the x-intercepts of the function here. X-intercept is going to be when y equals 0. So I'm going to replace y with 0 and say that's equal to 3x squared minus 11x plus 10. Now, because I don't have a common factor and a is not equal to 1, I'm going to have to use decomposition. I'm going to start by taking the a value times the c value, or 30, and I need two factors of 30 that add up to the b value of negative 11, and I'm going to get negative 5 and negative 6. So I'm going to split up that middle term, and I'm going to say that this is going to be when 0 is equal to 3x squared minus 5x minus 6x plus 10. I factor these by grouping. And in the first case, all I can pull out is the x, and I'm left with 3x minus 5. In the second case, I'm going to divide by negative 2, and I get 3x minus 5. I know I'm doing it correctly because what's in the brackets matches. So the factored form of this is going to be 0 is equal to 3x minus 5 times x minus 2. Then I'm going to take both these factors and I'm going to solve if either 3x minus 5 is equal to 0 or x minus 2 is equal to 0, then this statement is going to be true. In this case, 3x would equal positive 5 when I add 5 to both sides, or x is going to equal 5 over 3. In the second case, x is going to equal 2 when I add it to both sides. So the x-intercepts are going to occur at the points of 5 over 3 and 0, or 2 and 0. The y-intercept I can pull from my equation. It's the c value. The y-intercept is going to occur at 0 and 10.